Now we'll find out Laplace transform of any complex signal. To find out the Laplace transform of any complex signal, आप लोगों को पता होना चाहिए कि Laplace transform of the basic signal or properties. No need to use the integration and the anything. So now let us start with the problem. The first is x of t is equal to u of t minus 5. So already we know the Laplace transform of u of t. So just you can use Laplace transform of u of t is equal to 1 upon s. And if you look at the signal x of t is equal to that u of t minus 5. So this is the time shifted signal. Original signal is u of t and u of t minus c, that 5, it is a time shifted signal. So you can use the property that Laplace transform of x of the t minus t0 is equal to e raised to minus s t0 into x of s. So Laplace transform of u of t matlab it is x of s is equal to here 1 upon s. And if you compare this x of t minus t0 with u of t minus 5, so the value of the t0 is equal to 5. So therefore you can use this property and you can find out Laplace transform of u of t minus 5. So here t0 is equal to 5. So this is equal to e raised to the minus s t0, e raised to minus the 5s into x of s is equal to 1 upon s. So therefore the Laplace transform of u of t minus 5 is equal to e raised to minus 5s divided by s. So accordingly, you can find out Laplace transform of anything by using the property. You state the property by using the time shifting property. Now let us look at another problem, that e raised to minus 2t u of t is a original signal x of t. So if they ask us to find out the Laplace transform of x1 of t, where x1 of t is x of t minus 5. So actually this x of t minus 5 is the time shifted signal. We are going to use the same property, that is the time shifting property. The first I will write the time shifting property, Laplace transform of x of t minus t0 is equal to e raised to minus s t0 into x of s. So here x of t is equal to e raised to minus 2t into u of t. So we know Laplace transform of e raised to minus at u of t is equal to 1 upon s plus a. So here the a is equal to 2. So same you can use just that the Laplace transform of e raised to minus at u of t. So this is equal to 1 upon s plus a. So this is x of s. Now this signal is shifted by the 5 unit of the time. So therefore, so x1 of t is equal to x of the t minus the 5. So this is equal to, here the t is replaced e raised to minus 2 into t minus 5 into u of t minus 5. Actually x of t minus 5 will be like this, and they ask us to find out this, and I will use the property of the time shifting property. So therefore the Laplace transform of the x1 of t is equal to x1 of s is equal to e raised to minus the t0 is 5, so therefore 5s, and Laplace transform of e raised to minus 2t u of t is 1 upon s plus a, so into 1 upon s plus a. So accordingly we can use the time shifting property to find out Laplace transform of any time shifted signal. You have to specify time shifting property and you can use like this. Now we'll find out the Laplace transform of another signal, that is a complex e raised to minus 5t u of t minus 5. So if you look at u of t, here u of t minus 5 is a time shifted signal, but here it is not shifted. So therefore we cannot apply directly the time shifting property to this signal. Now let us assume let x of t is equal to e raised to minus 5t into u of t. So this is my basic signal. I will use, I know Laplace transform of e raised to minus at u of t. So same property I will use, and I will find out the Laplace transform of this signal. So Laplace transform of this signal is equal to 1 upon s plus a. That is a is equal to 5. It is equal to 1 upon s plus 5. Now I will use the time shifting property, the Laplace transform of x of t minus t0. So this is equal to e raised to minus s t0 into x of s. Here x of s is 1 upon s plus 5. Now what I will do, I will shift this signal entirely by the 5 unit of the time. So therefore the x of the t minus 5 is equal to e raised to minus 5 the t minus 5 into u of the t minus 5. So here both this t and this t are shifted by 5 unit of time. So this I can write e raised to minus 5t into e raised to 25 into u of t minus 5. Now I have to find out the Laplace transform of this time shifted signal. So the Laplace transform of x of t minus 5, so which is equal to Laplace transform of e raised to minus 5t into e raised to 25 into u of t minus 5. So this is equal to e raised to minus st0. Here the t0 is 5. So therefore e raised to minus 5s into x of s, into I will write x of s. So this is equal to e raised to minus 5s. So x of s is 1 upon s plus 5. It is s plus 5. But I have been asked to find out the Laplace transform of e raised to minus 5t and u of t minus 5. So this is the additional term. So I will take this additional term to this side so that I will get the Laplace transform of. So Laplace transform of e raised to minus 5t into u of the t minus 5 is equal to e raised to 25 is this side. So if I will take to this side, so it will come to the denominator e raised to 25 and for the numerator e raised to minus 25. So this is equal to e raised to minus 25 into e raised to minus 5s divided by the s plus 5. So this is the Laplace transform of this signal. So which is equal to e raised to minus 25 into e raised to minus 5s divided by s plus 5. So it is the Laplace transform. It is just this one is the additional term. Most of the time they may ask you to find out such kind of the problem, so you don't apply directly the time shifting property. So first you apply this time shifting to whole signal, so then you expand the term, you find out the Laplace transform, whatever additional term will be there you take to the right hand side. So accordingly you will get the Laplace transform of such kind of signals. Okay, now we will make use of the frequency shifting property. So these are some problems which can be solved by using frequency shifting property. Already I told you कि Laplace transform of basic signal plus property will help us to find out Laplace transform of any complex signal. Now the first signal we will take e raised to minus at cos omega 0 t u of t. So you know the frequency shifting property. Once again I will explain you the frequency shifting property. Laplace transform of e raised to minus at into x of t. That means if any signal is multiplied in the time domain by e raised to minus at, so its Laplace transform is equal to x of s plus a. If it is minus, it is plus, it is shifted in the frequency domain. So just you apply this property wherever s is there, you replace s by s plus a. So that's it. So we know, therefore you can write the Laplace transform of cos omega 0 t into u of t is equal to s upon s square plus omega 0 square. That already we know. Now this signal is multiplied in the time domain by e raised to minus at. It means we have to apply frequency shifting property. So this is the cos omega 0 t and u of t. So Laplace transform of cos omega 0 t u of t, that is x of s is s upon s square plus omega square. And if it is multiplied by this the e raised to minus at, means it is a frequency shifting. Wherever s is there, you replace by s plus a. So this is equal to, here s I will replace, it is multiplied by minus a, so it is s plus a divided by s again is replaced by s plus a square plus omega 0 square. So this is the Laplace transform of e raised to minus at cos omega 0 t u of t. Just you specify by using the frequency shifting property. Similarly the problem is same. You can use the same the frequency shifting property. So Laplace transform of the sine omega 0 t u of t. So this is equal to omega 0 upon s square plus omega 0 square. And this is multiplied by using the frequency shifting property e raised to minus at into sine omega 0 t u of t. So this is equal to omega 0 divided by wherever s is there, you replace s by s plus a square plus omega 0 square. That's it. Within 2 steps we will get answer. Same we will see another problem here. So if it is 4 e raised to minus 2t cos 5t minus e raised to minus 2t sin 5t u of t. There are two signal. One is x1 and another x2 signal. So the Laplace transform of x1 plus x2 is x1 of s plus x2 of s. By using a linearity property, you can specify by using linearity property, and so it is multiplied by e raised to something. So frequency shifting property. So by using linearity and frequency shifting property. So you have to specify because you will get marks unless until you specify this you don't get full mark. So therefore the x of s here I will write is equal to, directly also you can write. So Laplace transform of this plus Laplace transform of this. So I will write Laplace transform of 4 into e raised to minus 2t into cos of 5t plus Laplace transform of 3 into e raised to minus 2t into sine of 5t into u of t. So here I will use this x of s is equal to, here the 4 is constant, so I will take 4. We know Laplace transform of the cos 5t u of t, that a cos omega 0 t is equal to s upon s square plus omega 0 square. Omega 0 is a 5. So s, and here it is multiplied by e raised to minus 2t. So wherever s is there, s will be replaced by s plus a. So therefore it will be equal to s plus 2 upon s square, means s plus 2 square plus omega 0 is 5 square is a 25. Okay, minus is there. So 3 is a constant. Again the sin 5t, its Laplace transform is omega 0, that is a 5 upon s square plus omega square. So this into 5 will be as it is, okay, divided by s square. So s will be replaced by s plus 2. So s plus 2 square plus this 5 square omega 0 square, that is a 25. So this x of s is equal to 4 into s plus 2 divided by s plus 2 square plus 25. Okay, and accordingly this is common both the numerator. So minus 3 into 5 is a 15. So this is Laplace transform of the above signal. So within 2-3 steps you can find out Laplace transform of any complex signal. Now we will solve some problem using differentiation in S domain property. Already मैं आप लोगों को बताया हूँ कि Laplace transform of basic signal और properties आपको पता है तो you can find out Laplace transform of any complex signal. Now differentiation in S domain indicates that if the signal is multiplied in the time domain by minus t, it may be minus t or minus t raised to n. So depending on this order of this minus t, so the signal is differentiated by the nth order in the S domain. So minus t raised to n x of t is equal to d s raised to n, that differentiation of nth order in the S domain, into x of s, where the x of s is the Laplace transform of basic x of t. Just you remember that property and just you have to compare and you have to understand that which property will be applicable. तो first signal हम देखेंगे कि x of t is equal to minus t into e raised to minus 2t into x of t. अगर इधर देखेंगे this signal is multiplied by minus t, मतलब कि differentiation in S domain property applicable रहेगा. So I will write this minus t into x1 of t. Okay, so let the x1 of t is equal to e raised to minus 2t into u of t. So we know the Laplace transform of e raised to minus 2t u of t. So therefore this x1 of s is equal to 1 upon s plus the 2 will be there. Now the Laplace transform of this minus t into the x1 of t is equal to, this we will use that property, that d by ds of x of s. Okay, so here it is multiplied by minus t, so first order differentiation. So this is equal to d by ds of 1 upon s plus 2. You use the differentiation of 1 upon s plus 2, that is 1 upon x, which is equal to minus 1 upon x square. So this is equal to minus 1 upon s plus 2 and its square into differentiation of s plus 2, so that is equal to 1. So the Laplace transform of this minus t e raised to minus 2t u of t, So is equal to minus 1 upon s plus 2 square. The same will go here, that here x of t is equal to t square into cos of omega 0 t into u of t. Here the minus t raised to 2 will write, that is equal to t square. So you just compare with the s domain property, minus t raised to n into x of t, and let x of t is equal to cos omega 0 t into u of t. So its Laplace transform is second order differentiation of x of s. So therefore let the x1 of t is equal to the cos omega 0 t into u of t, and its Laplace transform already we have seen is equal to s upon s square plus omega 0 square. Now it is a multiplied by minus t, so therefore x of t is equal to minus t square into this x1 of t. So Laplace transform of this, the x of t is equal to second order, so d2 by the ds square into x1 of t is x1 of s, that is s upon s square plus omega 0 squares. So accordingly you can use the differentiation and you can find out the Laplace transform of this particular signal. The third we will also see. So x of t is equal to minus t into u of t minus 5. Again multiplied by minus t in the time domain. So that is nothing but again differentiation in the s domain properties. So therefore we know the Laplace transform of u of t is equal to 1 upon s. Laplace transform of u of t minus 5, that is differentiation time shifting property you can use. So this is equal to e raised to minus 5s divided by s. Now again it is multiplied by minus t. So therefore Laplace transform of this x of t is equal to d by ds of e raised to minus 5s divided by s. So here you can use the property that differentiation of that u by v is equal to, so v into du minus u into dv divided by v square. So this is equal to this as it is s into differentiation of this is e raised to minus 5s into minus 5 minus u means e raised to minus 5s as it is, differentiation of s with respect to s is 1 divided by s square. So this is the Laplace transform of minus t u of t minus 5. इसमें हमने we have used two properties. One is the time shifting property. उसके बाद again multiplied by this minus t we have used here the differentiation property. इस तरह अगर कोई भी complex signal आपको दिया है तो उस complex signal का just by using properties you can find out Laplace transform of any basic signals. Okay, now we will solve problem with the help of the convolution in time domain property. We have seen that the convolution in the time domain corresponds to multiplication in the frequency domain. So convolution is a complex operation, उसको बहुत time लगता है and memory भी ज़्यादा लगता है. तो same अगर signal आप Laplace domain में अगर transfer करेंगे, so it is just a multiplication. So many complex operation in the time domain makes very easy in the different domain. Now let us solve problem of the Laplace transform of x of t, where x of t is equal to e raised to minus 5t u of t convolved with e raised to minus 2t u of t. There are two signals. You can assume it as x1 and the x2 और उसका आपको convolution find out करना है. So convolution difficult, so we will make use of the property of the convolution in the time domain. Now you can write let x1 of t is equal to e raised to minus 5t into u of t, and let x2 of t is equal to e raised to minus 2t u of t. Okay, now you can write x of t is equal to x1 of t convolved with x2 of t. Now write by using convolution in time domain property. Convolution in time domain property, that is which is specified here. So you can write, so the Laplace x1 is e raised to minus 5t u of t. So x1 of s directly you can write, already you know Laplace transform of e raised to minus at u of t is 1 upon s plus a. So it is equal to 1 upon s plus 5. Then x2 of s, Laplace transform of e raised to minus 2t u of t is equal to 1 upon s plus 2. So therefore, Laplace transform of this whole signal, that x of t, that is x of s, is equal to x1 of s into x2 of s. So this x of s is equal to 1 upon s plus 5 into 1 upon s plus 2, that is s plus 2. So it is the final answer of this problem. So many problem will be made very easy in the S domain. Such kind of problem will be asked where this problem may consist of some complex problem which consists of the time shifting or frequency shifting property. So you have to solve Laplace of this, then find separately Laplace of this problem, and you multiply. Finally you will get Laplace transform, that is a convolution in the time domain which corresponds to multiplication in the frequency domain property. Now we will solve some problems based on the initial value and final value theorem. This initial and the final value theorem is very useful to find out value of the signal before the time t is equal to 0 or value of the signal at the time t is equal to infinity, which is difficult to find out. So this Laplace theorem help us to get the values of the initial and the final value of the signal. तो इनिशियल वैल्यू थ्योरम है कि x of 0 प्लस जस्ट आफ्टर टाइम t इज इक्वल टू 0 अगर फाइंड आउट करना है लिमिट s टेंड्स टू इन्फिनिटी s इंटू एक्स ऑफ s, और फाइनल वैल्यू थ्योरम है x ऑफ इन्फिनिटी इज इक्वल टू लिमिट s टेंड्स टू 0 s इंटू एक्स ऑफ s. अगर इनिशियल है तो हियर द लिमिट विल बी s टेंड्स टू इन्फिनिटी, अगर आपका फाइनल वैल्यू है तो लिमिट इज s टेंड्स टू 0, दैट यू कैन रिमेंबर, and s into x of s is a common here in both the cases. Here the problem is find the initial value of the signal x of s. The two problems are given. So first we will go x of s is equal to 3 divided by s square plus 5s minus 1. So first you write the initial value theorem. The initial value theorem states that x of 0 plus is equal to limit s tends to infinity s into x of s. So just you write, so this is equal to limit s tends to infinity s into x of s. X of s is 3 divided by s square plus 5s minus 1. So it is equal to 3 into s divided by s square plus 5s minus 1. Here only you see that when you are substituting the values of s is equal to infinity, so the value of the signal directly in the numerator, it should not be substituted as s is equal to infinity. So in the numerator you try to convert that s to the form 1 upon s, or only that the constant value will be there. So directly if you substitute infinity, so it will become infinity. So instead of that you try to convert this to the only that constant value or 1 upon s. So what I will do, so I will divide the numerator and the denominator by the s. So this is equal to limit s tends to infinity. So 3 s divided by s is s, s square by s is s, plus 5s divided by s is a 5 minus 1 upon s. I have divided numerator and the denominator by the s. So here if you look any signal that try to convert to the 1 upon s. So here it is not possible to convert the s to 1 upon s, because again here it will become, if you try to convert, so again 3 divided by s will be there, again its value will become 0. So you cannot again go beyond converting all the terms to the 1 upon s. So now this is the final term by converting all the terms to the 1 upon s. So you substitute s tends to infinity. So this is equal to, here s is a infinity, here 1 upon infinity is a 0. So here it is a 3 divided by s is infinity plus 5. So this is equal to 3 divided by infinity. So anything divided by infinity is equal to 0. So initial value of this signal x of 0 plus is equal to 0, anything divided by infinity. Then similarly next problem we can take. So x of 0 plus is equal to limit s tends to infinity s into x of s. So this is equal to limit s tends to infinity s into 2s plus 3 divided by s into s square plus 5s plus 6. So you can the cancel s and s which are the common. So this is equal to limit s tends to infinity 2s plus 3 divided by s square plus 5s plus 6. Again, you try to avoid the term s where directly we can substitute the infinity. So you try to convert. So I will divide numerator and the denominator again by the s. So this I will get the limit s tends to infinity. So 2s divided by s is a 2 plus 3 divided by s divided by here the s plus 5 plus 6 by s. So you now substitute the s is equal to infinity. Again here it will be zeros. Again the infinity plus anything, it is infinity. So it is 2 divided by infinity. So this is equal to 0. The initial value of this signal is also equal to 0. So accordingly you can find out the initial value of any signal. Now let us see some problems on the final value. Then we will find out the initial and the final value of any signal. Now we will find out the final value of the signal. So already we know that the formula for the final value of the signal, that to find out x of infinity is equal to limit s tends to 0 s into x of s. So just we will use this formula to find out final value of the signal. The first problem is x of s is equal to 1 upon s minus 2. Just to use the formula so that the x of infinity is equal to limit s tends to 0 s into x of s. So x of s is already given. This is equal to limit s tends to 0 s into x of s, that is a s minus 2. Okay. So here if you look, sometimes what happens, there are some typical the problems are there. So if you look at this x of s, so that the pole is located at s is equal to minus 2. That if you plot the s domain signal, sigma and the j omega, s is equal to 2 is the pole is located at the sigma is equal to 2. When the pole is located at the positive side of this j omega axis, that time always you remember x of infinity is equal to, it is infinity, because such kind of the signal are the growing signal. Such type of the signal, because if you look at its inverse Laplace transform, that is 1 upon s minus 2. Its Laplace transform, inverse Laplace is e raised to 2t and it is u of t. So if you plot this signal in the time domain, so it is just growing signal. After time t is equal to infinity, it is going to become infinity. So therefore, for such kind of the signal, when the poles are located to the right hand side of this j omega axis, so always x infinity is equal to infinity. So instead of substituting and cancel the term, so accordingly you can find out the final value of the signal. Same we will go for the next signal, that again the x of infinity is equal to limit s tends to 0 s into x of s, that s into s minus 1 divided by s into s plus 1. So here you can cancel both the s in the numerator and the denominator, and you will get this is equal to limit s tends to 0 s minus 1 upon s plus 1. So here you try to avoid the 1 by s here, that is a 1 by 0, which will become infinity. So here none of the term is going to become the infinity. So directly you can substitute s is equal to 0, that 0 minus 1 divided by the 0 plus 1. So this is equal to, it is coming out to be minus. So x infinity is equal to minus 1. Again this is also typical problem. Okay, 1 upon s square plus 4. So again you see the poles, that s square plus 4 is equal to 0, that s square is equal to minus 4. So s is equal to plus or minus j4. So the poles are located on the j omega axis. When the poles are located on the j omega axis, so that time the final value of the signal is not defined. So again you write the formula here, that x of infinity is equal to limit s tends to 0 s upon here s square plus 4. So here s square plus 4 means it is a sinusoidal signal. So generally sinusoidal signals, the final value is not defined. So therefore you write the poles are complex conjugate. Poles are complex conjugate. So therefore, so x infinity is not defined. For other signal, so directly we can substitute the values of s as a 0, but you try to avoid 1 upon 0, where such kind of terms will become infinity. So if s is there, you can substitute s is equal to 0 and you can find out the final value of the signal. Okay, अभी हम लोग कुछ लैपलास ट्रांसफॉर्म देते हैं और दे विल आस्क यू टू फाइंड आउट द लैपलास ट्रांसफॉर्म सम एनी अदर कॉम्प्लेक्स सिग्नल. उस टाइम आपको प्रॉपर्टी याद करना है और आपको कंपेयर करना है कि कौन सा प्रॉपर्टी उसको एप्लीकेबल है, उस हिसाब से आप प्रॉब्लम सॉल्व कर सकते हैं. तो लेट अस सी वन प्रॉब्लम. एक्स ऑफ एस इज इक्वल टू एस प्लस 2 डिवाइडेड बाय एस स्क्वायर प्लस 4s प्लस 5, and they asked us to find out the Laplace transform of y1 of t, where y1 of t is equal to t into x of t, y2 of t is e raised to minus t x of t, y3 of t is equal to x of t convolved with x of t. Now let us go for the first problem, that y1 of t is equal to t into x of t. हमने देखा है कि t into x of t, when the signal is multiplied by the t in the time domain, it is equivalent to differentiation in the S domain property. So that is Laplace transform of minus t into x of t is equal to d by ds of the x of s. अब हमें बोला है कि t into x of t. Now we will find out the Laplace transform of the t into x of t is equal to this minus, हम इस साइड को लेंगे, minus d by ds of x of s. अभी हमें x of s पता है, so I will write this is equal to minus d by ds of s plus 2 divided by s square plus 4s plus 5. So now differentiation of the u by v. So this is equal to minus, this denominator will be as it is, s square plus 4s plus 5 into differentiation of the numerator, s plus 2 उसका 1 रहेगा, minus the numerator will be as it is, then the differentiation of the denominator, that is equal to 2s plus 4 divided by denominator square, that is s square plus 4s plus 5. So it squares. So accordingly you can simplify this problem, so that the y1 of s is equal to, you can write s square plus 4s plus 5 minus, you can write s, that 2s square plus 4s plus 4s plus 8 divided by s square plus 4s plus 5 bracket square. So accordingly you can simplify and you will get the Laplace transform of this particular problem. The second, they have asked us to find out the Laplace transform of y2 of t, so which is equal to e raised to minus t into x of t. So we have seen the property, when the signal is multiplied in the time domain by e raised to minus at, that is equivalent to frequency shifting property. So that Laplace transform of e raised to minus at into x of t is equal to x of s plus a. Now if you compare this a with this, so a is equal to 1. So therefore Laplace transform of e raised to minus t into x of t is equal to x of s plus 1. So this is equal to, wherever s is there, you replace by s by the s plus 1. So s plus 1 plus 2 is equal to s plus 3 divided by s plus 1 square plus 4 into s plus 1 plus 5. So this problem is also over. Third is very easy, that the convolution in the time domain corresponds to multiplication in the s domain. So that y3 of s is equal to x x of s into x of s. So this is equal to s plus 2 divided by s square plus 4s plus 5. So its whole square. So this is the Laplace transform of convolution of the same signal in the time domain corresponds to multiplication in the frequency domain. So such type of problems will be asked in the exam. So accordingly you can make use of the property and you can solve. It's accordingly so much each. The next we will see sometimes they will give the problem. In the time domain they will give the signal and we have to find out. So when such type of problems are given, you try to express such kind of the signals in the mathematical form. तो आप लोगों को mathematical इसका equation करने के लिए आना चाहिए. For example, if the signal is like this, so this is 0 and this is 1, this is t, so this is x of t. This signal is developed from the unit step signal. अगर आप देखेंगे already we have studied. So this is the u of t and another signal, if this is the delayed signal 1, so this is u of t minus 1. When I subtract u of t minus 1 from the u of t, so I will get this signal that u of t minus u of t minus 1. So this signal will look like this. So this is 1, this is 1. So it is like this. So accordingly every part of this signal sabhi part hai, so you write its mathematical the equation of this signal. So I will write, so x of t is equal to, so this can be written as u of t minus u of t minus 1. So it is about this signal plus second part. So this starts from the u of t minus 2. So u of t minus 2 minus u of t minus 3 iska signal plus this part. So this can be written as u of t minus 4 plus u of t minus 5. Okay. Now you find out its Laplace transform by using property. We know Laplace of u of t is 1 upon s. It is 1 upon s minus. It is time shifting property. U of t का 1 upon s है. So x of t minus t0 e raised to minus s t0. t0 is equal to 1. So e raised to minus s divided by s plus e raised to minus 2s divided by s minus e raised to minus 3s divided by s plus e raised to minus 4s divided by s plus e raised to minus 5s divided by s. So यहाँ पे just, so it is minus, so x of s is equal to 1 upon s 1 minus e raised to minus s plus e raised to minus 2s minus e raised to minus 3s plus e raised to minus 4s minus e raised to minus 5s. So this is Laplace transform of above signal. Like if they ask you like the Laplace transform of such kind of signal, if suppose 0 it is 10, so this is t, okay, this is x of t. तो इसको आपको you first write mathematical equation that u of t minus u of t minus 10 और इसका Laplace transform find out करो. So accordingly you can find out Laplace transform of any signal. One more problem we will see. So here find the Laplace transform of x of 2t if x of s is given. So just if you compare the property, so this is equal to time scaling property. So time scaling property states that Laplace transform of x of at is equal to 1 upon a into x of s by a. आपको ये just you recall this property. So x of s is given. Wherever s is there, you replace s by s upon a. And if you compare this equation, so a is equal to 2. So x of s is equal to Laplace transform of x of t. So this is equal to 2s upon s square minus 2. So therefore Laplace transform of x of 2t is equal to, by using the time scaling property, so 1 upon a, that is a 2 into s is replaced by s upon a, at s by 2, so s by 2 square and like this. So this is equal to 2 to get cancel. So s by 2, okay, divided by, you can write it is a s square minus s square by 4, it is minus 2. So this is equal to s by 2 divided by s square minus 8 divided by the 4. So overall you can write this equal to s by 2 into 4 upon s square minus 8. So this is equal to 2s upon s square minus 8. So accordingly you can use the property recall and you just substitute accordingly values, you will get Laplace transform of any complex signal.